we have another week of lecture to go. Okay, so today what I intend to do is to do a combined loading analysis with 3D mold circle, and then we are going to go through the last topic. So this is the final topic, which is on ductile yield criteria. Okay, and because of time constraint, I'm just going to teach one criteria. Usually I teach two, but I'm just going to focus on one. Okay. Final exam, it will be held on August 7th. And if you were to, there'll be 3 questions. And I'd like to remind you all that this one is on a Thursday. Okay, usually we have it on a Friday, but this one's on a Thursday. And then it's going to be from 1830 and to 2100. Okay, 3 questions. And it will be from, can't remember which homework it will be from now. I need to check. So there is another homework coming. So if we look at the homework, if I'm going to look at on Avenue to Learn. So you'll be from homework 05, and we are going to go until homework 08, and homework number 8 will be the last homework that you'll be receiving, and I'm uploading it tomorrow. Okay. Right. So now we are going to look into a combined loading with 3D mold circle, and I'm going to pick up a problem that you've seen before, and it is this problem over here. Okay, so when we did this problem in probably week 6 or week 7, we did not consider shearing stress. Okay, so now I want to incorporate shearing stress, and also we're going to incorporate 3D mold circle. Okay, and this is a true engineering work. Okay, so in real life, this is what you're expected to do, and for this course, you're expected to know, okay, in detail how to do a complete structure analysis. Okay. Okay, let's look at this problem again. Okay, so today we're going to combine shearing stress. Okay, so I'll write down here what's so unique about this problem. Now this problem is on Avenue to Learn. Okay. So it states that we have a beam with 4 applied force, and the beam use is W200 by 41.7. We are going to determine the principal stresses, and also we are going to determine maximum shear stress at point A, and we are also going to do point B. Okay. If you realize what we did before, we just calculate normal stress. Okay, we did not determine principal stresses. So this problem, okay, require the knowledge from the following. Okay, so number 1, we have to identify the axial force, bending moment, and shearing force. Okay, or shearing forces. So that is the first thing that we have to do. And then why we have to identify this, because we have to know so if we look at the transformation, which I'll draw later, the stress that this one, I think you are very good at it, is PZ over A plus or minus My over Iyy multiplied by Z, and then plus minus Mx. Oh no, this is X. I do apologize. And then we have Ixx multiplied by Y. Okay. So that is for the normal stress. So we have identified our PZ, My, and Mx. And then the next thing that we have to do, right, we have to relate the shear, which is equal to Vx over Iyy multiplied by Qy over T. And then again, the first term over here, you have plus or minus, and then you have plus or minus over here, and we have to use Vy over Ixx Qx over T. Okay, so this is the second thing that we have to do. And then we have the third thing. Okay, and then the fourth thing that we have to determine now is we have to now sketch our element. Okay. Right, we have to sketch our element. And we need to know, so if this is my, I call this my Z, and over here, this is my X. Let me look at the, yep, and then this is our Y. So we know, given a structure like this, we know that we are going to have stress Y, no, sorry, stress Z, normal stress Z. And we also have shearing stress. So shearing stress, the intersecting, the plane intersecting the Z, going up the Y, okay? And then we have the intersecting plane Y, the direction is in our Z. So from here, after we get to here, the next thing we have to do is we are going to apply 3D Mohs circle. Okay. So with 3D Mohs circle, we understand this is just a path of your knowledge you have to know to solve a problem like this, okay? So you have normal stress, you have shearing stress, okay? We are very sure that point X is here. And then I'm just going to sketch over here. This is our point Z, and this is our point Y. Then we sketch our 3D Mohs circle. Okay. 1 circle, 2 circle, 3 circle. And then from here, we determine our stress max, and then we determine our stress mean. Okay. And then with these values, what we can do, right? So I'm going to go to the textbook again. I need to leave some data. Okay. So I need to leave a, where? Pardon me, okay. Then we given a table, or we go through a table like this. Okay, so what you see over here is from a material handbook, right? So this is from a material handbook. Okay. Then from here, knowing that we now understand that all these values are over here, all these are our principal stresses. Okay. So from here, we can also determine our factor of safety will be equal to our stress yield divided by our stress max, or it can be our stress yield divided by our stress mean. Okay, so if you look at the process now, right, this is the entire course, okay, into one question, excluding buckling. We clear? Okay, so we did not need to do buckling analysis for this. Okay, in real engineering problem, sometimes, okay, you are required. For this case, okay, where my syllabus teach, okay, I don't intend to include buckling, but if I were to include buckling, I think you guys will have no problem also. Okay, so you can see, right, every topic that you learn after buckling is required to solve a problem like this. Okay, so I have students usually ask me, final exam, what are the topics? You have to have all knowledge from normal stresses, 2D Mohs circle, 3D Mohs circle, shearing stresses, okay, combine everything, okay, and then later on we have another topic which we have to combine, is known as the ductile yield criteria. Okay, so let's see how we solve a problem like example number 1. Okay, now the unique thing now is we have a situation where we have to determine our shearing stress. So take this like a revision initially, okay, until when we take this as a overall revision, okay, excluding yield criteria, okay, excluding yield criteria, okay. So we're going to go from here, right? So what we are going to do now, I'm going to take this problem over here, and like before, we draw our transformation in 3D. So we know that this is X, this is Y, and this is our Z. Okay. So we are going to look at our planes first. So we are going to look at our YZ plane. So if we were to consider a YZ plane, right? Then we have a structure like this. Then we have lines coming down. This thing is built in over here. And then we have our geometric centroid. We sketch our geometric centroid first. Then we put in our load. So over here, this is our 100 kilonewton. And then we have our 25 kilonewton. And then we have forces. This is 8 kilonewton. And this is 8 kilonewton. Okay. So from here, we can see that we sketch our element of interest. So over here, this is our element A. Over here, this is our element B. Okay. So from here, we know that we have our PZ. PZ is going to be 100 times 10 to the power 3 Newton. Okay.